Uh, Savita, can you see the video and hear me now? Are you able to hear me? So Girish and Savita is able to hear me. Yeah. PPT is coming up. All right. Now can you hear? Can you see the screen with the PPT? Okay, great. So I'm extremely sorry, my machine got rebooted and yeah. All right. So what I was trying to demonstrate is, I think I got logged out. SSH student at Hadoop 1. All right. I was in a HBase shell. We were saying scan my table. So we were talking, oh, we had deleted the table. Okay. We had deleted the table. All right. So let me just try to scan some data. Let's say, scan EMP. All right. So this EMP has got column called personal and then row ID is 1 and so on. Okay. And value is Vikas. For this particular column called personal data column name, personal data is the name of the column family and name is the column name under this particular column family. Okay, so this is a fully qualified name of a column is personal data column name. Okay, similarly you can have a look at scan. Okay, here also, here SGCF is the column family name and column 1 is the column name. All right. So let's say that my first table, what does it have? First table, scan my first table. Okay, now you can see that there is a one row key called Anand row ID. Second row key is my RK1. Third one is my RK2 and so on. And here there is a one column family called CF1 and so on. Alright. So this is how you can access the data. And actually, you would be wondering where is HBase storing all of these tables which we are creating from this HBase shell. Any HBase table which we are creating is actually getting created in HDFS. Let's have a look at it. Let's have a look at it. It's stored in this location. You could go to Hue, for example. You could go to Hue. And then you can go to the file browser and here you can edit the path, put that folder, and see under app hbase data default, all of our tables are existing, aren't they? Whatever table we were browsing, there is a folder for each table. So if we have 20 June table, under each table, what is next? After table name, the reason ID. Okay, so this is the reason ID. This is the reason ID. All right. What is this? Okay, this is the reason ID. Under this reason ID is automatically generated every time the table is splitted, a reason ID is generated, and by default there is a single reason. And under this reason ID there are two column families, column family 1 and column family 2. And then if you move forward under the column family, all of the data of a column family of one reason is in a single file. Okay, now when I said that it's a column family oriented database, this is what I meant. All the data for a column family is stored in a single file. All right, and again this particular file is on HDFS, which means there are 3 replica copy of this, and every time HBase wants to read it, at least one of the replica would be available and will be closer to HBase node, the node which is trying to access this particular file. Alright, does it make sense to you? So you can see that CF1 is having this particular data, and this data is formatted in the particular format provided by HBase, and that can be accessed. Because under the hood this table is in the binary format. Okay, make sense to you? All right, any other questions related to this? Okay, we have already talked about locking, and when we talk about, I'll just take it, I'll give you a very cursory view of how the scanners work. So just like in our normal database, whenever we are trying to access the database, we have certain API. That API, there is also an API for HBase. And to understand that API, we need to understand what is a scanner. So scanner is similar to cursors. We get hold of a certain row and we can keep on moving further and further to next row key and get the data. So each scanner, so we create a scanner, we get a scanner on top of a HBase table, and then we execute a scan. The way we said scan, that was for full table, we could do partial scan as well. The way we said earlier, get particular row key. In the similar manner, we could start our scan on an HBase table. And what do we require for starting a scan? we need to we need to provide a scan parameter which need to specify On which row should we start scanning? On which row should we stop scanning? And when I say row, row means row key. And which columns do we need in the output? It is very important to mention the columns. Otherwise, as we saw just now, that there are multiple column families, right? And multiple column families having multiple files. And if your columns are across multiple column families, then you are going to read multiple HBase files in order to retrieve multiple columns. Okay, so it's very important to be very specific when we talk about columns in an HBase table, and make sure that when you are trying to scan and when you're trying to optimize the scan, make sure that in a single scan you are trying to read only one column family. That way you will be only reading a single file from HDFS. Otherwise you will be reading multiple files, as we showed you that each column family has a single file, right? Therefore, it is very optimum, and that's the reason why you define a column family. If you know that certain information is going to be accessed again and again together, if certain columns are going to be accessed together, you put them in a single column family. Make sense to you? Next is that you could also provide some sort of a filter which can basically check a particular row's values whether they qualify to be put in the output or not. Okay, this filter is generally a very heavy one, because it is going to, for each row this filter is going to get executed. And whenever you are running the scanner, after you have got the handle to the scanner, you can say, give me next n number of rows. And every time you say, give me n number of rows, it is going to make a trip to the server. Now, Damodaran's question is regarding atomicity. Updates, updates rows across different regions is mutually exclusive or not. Okay, so whether you are updating in one one column family or another column family, all of that is a part of a transaction. Okay, if that is what you mean. So if you have a need that in a single transaction, or in a single shot, I should be able to update one column family of a row and another column family of a row, add few columns in one column family, delete one columns from another column family, and so on. You can do all of that. You can do all of that using the you can do all of such kind of operations in HBase, and you can do all of that in a single transaction. Was he able to answer, Damodaran? Column family names, I think that's what you meant, Praveen. So column family values should be unique. Do you mean to say column family name? Yeah. So first, column family name have to be unique. There cannot be two column families with the same name. Second, a combination of column family name and column name has to be unique. All right. A combination of a column family as well as a column name has to be unique, which also means that columns with the same name can exist in two different column families. Arvind's question is, Arvind's question is there any locking when one user is trying to read the data while other is trying to update? So if one user is trying to read the data and other user is trying to update, that row gets locked, and user will not be able to read the data while the updation is happening. Okay, good question. All right. So the transaction makes sure that that happens properly. Okay. So when we are scanning the data, we could use scanner, and this is how it generally looks like. Although the code looks really ugly, but it's a extremely simple. So you first create a configuration. You create something called admin instance. This is the admin. Using this admin, we'll be doing all the operation. But before that, let's say we are trying to create a table called test, and then we are trying to add these column families to our table. Okay, so what we have done, we created first one table descriptor, then we defined a column descriptor, and we added a column family with this name in htd. So table descriptor dot add family, and we have given our column name, and after that we are saying create my table with a handle called htd. This one will create a table with these column family. And once we are done with that, we can read it in a similar fashion. This code is for reading the same data. So first what we do is we say admin.list tables. This gives us the list of tables which are there in the in our HBase. Now we can iterate over the list of tables and make sure that we can list the tables in our database and make sure that our table which we were trying to exist already exists or not. If it is not there, that means that we could not create the table. Once we had successfully checked that our table has been created, we can add we can add the data into we can add or retrieve the data from it. And the way to add the data is first you create a byte array representing the row key. This is the way you first convert your data, the text data, into the binary data. And on top of the binary data, you create a command called put. So after you've created a command called put, and similarly, this is the value which we are going to do, and we convert that into binary data. And afterwards, we say P1, as in P1 is our put. Okay, put command. We are saying P1 dot add. This is our data, and this is our P1 dot add. I mean, for this row, we are adding this data. These are the multiple columns which we are trying to add. And afterwards, in the similar fashion, we can start getting the data from the row, right? So that was a little. You can have a look at the full API in case of HBase from their documentation. Probably their documentation, the most updated source of information regarding the API, not any book or not any other tutorial. Okay, so go through the documentation if you are to access the HBase from Java. Okay, also note that HBase also provides you a, a service API from which you can read and write the values without having to worry about Java code. All right. Also, you can run mapper and reducer on top of HBase table, and that is very big strength of an HBase. So you could see clearly that there was no there we did not have any SQL kind of language part of the core HBase. Though there are third-party drivers which convert the SQLs into the get and put internally. Okay, but HBase does not provide you an SQL kind of interface. All right. Now, when you have to execute a large amount of computation on HBase, it is more sensible to use HBase's map and reduce. The way when we when we executed our normal MapReduce, they executed against the files, and those files were in HDFS. Here, any mapper logic first get executed against HBase table. Okay, mapper logic gets executed against HBase table. So the input to our mapper is going to be each row of the database table. So you can see that we are saying my mapper extends table mapper, text and int writable. Here, here these are the key and the values of our row. All right. So you can see that we are saying run our map against the row. This is the row which comes in the input of our map, and this is the value. And here we are only specifying, I'm sorry, here only specifying the output key and value. Okay, because input is fixed, input is the data row. All right. So we can have things like this, and afterwards we can. All right, so the input to our map function is going to be a row, and then this is the context in which we will be putting our value, and we can, and also the result, whether it was successful or not, is something we can put in into the value, and into the context we will be writing the key and the value, just like our usual mapper reducer. Inside the reducer we will get the data in this format, and each reducer can give the output in the form of the key and the value. Okay, so we get some key and the list of values, and then we give out the data in the form of key and values. All right, and once we are done with writing the key mapper and reducer, we can create, similar to our driver code, we can stitch it using HBase configuration object, and then we can say that initiate my mapper job, provide the source table name, provide a selection of that full table in case you do not want this mapper reducer to be executed on the whole table, because these tables are really humongous when it comes to production. And we could also mention we have to mention the name of the mapper, and we'll have to mention the data types which mapper is going to give us. Okay, and we can initiate our reducer job, and all of them is being stitched through the job. Okay, for this job we have created a mapper job, for this job we have created a reducer job, and once we are done with that we can also set how many reducers do we want, and then we say job dot wait for completion and then say true. That means it is going to get executed and we will have to wait for it to finish the execution. All right, so this is how we create the mapper reducer on top of our HBase. Okay, we will also show you how to access your data in the HBase through an API. All right, so Damodaran's question is, what does this get byte means? Get byte converts any string into bytes. You can see everywhere you will see these kind of data. See, cf.getByte, meaning convert cf, which is a text string, into an array of bytes. All right, so let's take a break for 10 minutes and we come back, and then we will discuss in detail about the Bloom filter, and then we will also see how to create a coprocessor, as well as we will show you how to access HBase from the REST interface. Alright? All right, so I'm back. Should we start now? Hi, I'm back. So can we start now? So it's only Subaredi and Carl. So Subaredi, Carl, Savita, and Praveen are back. All right. So now we are going to discuss Bloom filter. So HBase comes up with a great feature called Bloom filter. It's internally enabled and you do not have to do anything to configure it, or you don't have to touch it at all. By default, it's enabled at HBase level and you do not have to do anything at all. Okay. The only reason why I'm discussing it right now because a lot of people seem to ask about Bloom filter in various kind of interviews because it's a general concept and it's a very important concept to learn about. So so basically a Bloom filter is a general concept of dividing the searching into multiple machines. Okay, if there is a imagine that there is a watchman who allows people to go into the building. There is a watchman sitting in front of the gate, and when people come to him, he has to look through hundreds of notebooks. Although inside the notebooks the data is indexed, but still it takes him long time to find the particular data. Okay, so in those scenarios we require multiple people to do the search instead of only one watchman doing the search. So so it was observed that most of the people who are coming to the watchman are not allowed to go in, meaning their names are not existing in the files. Therefore, therefore, if there is somebody who could quickly check whether a person can go or not, and then there is somebody who can confirm that, it would be easier to do. So imagine this. Instead of having one watchman to check people's name, now we have got two watchmen, A and B. All the users first come to A, and then if user A says, okay, you can go in, but first confirm from B. And then B confirms that, okay, this person can go or not. Okay. So therefore, there are always two kind of a filter. First is called Bloom filter, and second one is the actual storage comparison. So So, I mean, the role of a Bloom filter is to do a quick check, maybe a dirty one. So, in case Bloom filter says you are not allowed to go, that's 100% correct. But if it says that, if it gives a result like, okay, you can go, that may or may not be true. Okay, that may or may not be true. So, let's say there is a person who comes up saying that my name is Key1. Filter might reject it. In case filter rejects it, then this user cannot go in. In case the another user comes in and says my name is key2, the filter might say yes. But then if the filter is saying yes, a reconfirmation, actual confirmation has to be done. Okay, actual confirmation might say yes or might say no. Okay, even though filter said yes, the actual storage might say no. But in case the filter says no, then it says no. Okay, let me take our first example. Let's say we will increase the font a bit, or let's say we are talking about bloom filter. Okay, let's say in our actual storage the data is Sanjeev, and say Damodran, or let's say here there is Savita, Damodran, and we have Karl, and we have Praveen. Now this is our actual data. In our say thousands of files are there is some similar data. Okay, so this watchman was busy. Every time user comes up, it goes into the list and tries to find their names. Okay, tries to find their names. Now what this new guy came in and said that let's devise a new mechanism. We'll put another watchman. So this was the watchman 1 who was having the this list of people. Now there is another watchman, or you can say another security guard who has come in called watchman number 0. Okay, we just call him 0. This watchman is only given a list of first two characters of each name. So he'll have SA, DA, and KA and PR. Alright? Or there could be Pratibha, and there could be Karthik. Alright? So for all of them, it'll have only these four combinations. So you can see that. Alright, although there are so many names, but out of them hardly, if you just pick up the two letter combinations, it will be hardly 26 into 26, these many, which is 576, total 576 list. Alright, so watchman 0 is the one who will do the first sanity check. So if a user comes and says my name is Sanjeev, so watchman 0 will let him go because his name is starting with first two characters SSA. Okay, but then watchman 1 will do the check and then say there is no Sanjeev listed in our list. There is Sandeep and Savita, but no Sanjeev. SANJEEV. All right. Similarly, in case let's say somebody called Jakir comes into and comes to watchman 0, so what will happen is watchman 0 will check whether ZA is there in the list and say no, why we don't have any ZA. Therefore watchman 0 will reject right away. So it gets rejected by watchman 0. Okay, while in case of Sanjeev, watchman 0 said yes. Watchman 0 said yes, while watchman 1 said no. Correct? Now, if there is somebody called Sandeep, and Sandeep has come in, so watchman 0 will say, okay, yes, we have a name, we have the first two characters as SA. So, and then watchman 1 will again do the check and say, yes, we really have Sandeep in our list. So we formed the bloom filter. This watchman called 0 is the Bloom filter, which basically checks only the first two letters. We could create Bloom filter in many number of ways. Okay, and generally we create the Bloom filter using various statistics technique such as generating the hash code and generating various other kind of numbers. So Watchman 0 decreases the load of Watchman 1 because these rejections are very high. But in case rejections are not very high, in case the 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 rejections, as in total number of people who are coming to Watchman 0 are valid users, in case they really exist, then rejections will be very low. Okay, and therefore they'll have to be checked again by the watchman again more. All right. Also, the other problem, so the way we choose the Bloom filter, we choose the Bloom filter such that there are maximum rejection possible at the Watchman 0 level, because otherwise there are going to be two checks. For Sanjeev and Sandeep, there were each cases we had to do check twice by the Watchman 0 as well as Watchman 1. Both of them had to run the checks. Okay. So Watchman 0 is the Bloom filter. Watchman 1 is the existing searching mechanism of any database. Alright, Sirisha, is that your question? Watchman 0 is the Bloom filter. So our database search was already in place, but we realized that our database search is getting overloaded. So we created a Bloom filter and let all the user pass through the Bloom filter and then reach the actual database. Sounds good to everyone? Is a Bloom filter clear to everyone? So although it's a very simple concept, but generally generally it's little difficult to digest. How come this Bloom filter is going to help us? Because if you look at it, it would look as if because of Bloom filter the records are being checked twice, first by Bloom filter, second by the actual database. So Damodaran's question is, how is duplicates handled? Is the search redone or previous data is cached? So which duplicates are we talking about? Let's say we had one more record here, Sandeep. Okay. For that, there will be SA only, nothing much. Okay. Is the duty of Watchman 1 to return duplicate record for a particular keyword? Did I answer Damodaran your question? So if we have Sandeep one more, the Watchman zeros index will still be SA. So now Damodaran's question is that record is having multiple fields. So if one field is different from other one, okay. So are you saying that our key on which we are looking for a record is composite key? Okay. So since in case of HBase or any other system like HashMap or anything, everywhere whenever we look for data, we look for a particular key. Unlike our usual database where we look based upon multiple column combinations, right? In here we always look for a key, and that's where the Bloom filter can be applied. Right. All right. Great. So I'm happy that I was able to answer. So Savita's question is that, let me just copy paste the question so that everybody can see it in case I'm reading it wrong. And let me just copy it. All right. So here is a question from Savita. All right. Great set of questions. Now we have, is the Watchman Zero list keeps on growing depending on what we have added in the Watchman 1 list. Okay. For example, if we add Suraksha, then does SU automatically add it to the Watchman Zero? Good question. So question is, who maintains and how is this Watchman Zero list maintained? Okay. How is that Watchman Zero list maintained? Okay. So few things to note. If we have already a considerable amount of data in Watchman 1, the chances of Watchman Zero list getting updated are very low. Okay. Second, whenever we are adding the Watchman ones, we are adding some records into Watchman ones list. We'll have to update the Watchman zeros list. It's as if we are updating the indexes of a table. All right. It's as if we are updating the indexes of a table. All right. Was I able to answer, Savita? Great. Now we have another question from Girish. Girish is saying, is Bloom filter like a virtual memory? Virtual memory is a little different concept. Virtual memory is when you load data into, when you don't have sufficient RAM, so you create a RAM, a virtual RAM out of the disk. Okay, that is my understanding of virtual memory. If I'm incorrect, please help me correct it. So So if that is your definition, then probably here we are differing a bit. Bloom filter is more similar to as if we are creating indexes of a table. It's vaguely similar to the indexes of a table, but has a very different connotation. Because in case of indexes, if we find something in indexes, that means it's sort it actually exists in the table. But if we do not find it, but that's not true in case of Bloom filter. Even if we find something in the Bloom filter, we may not find it in actual data. But if we do not find something in the Bloom filter, it will never be in the actual data. Damodaran's question is, so was I able to answer your question, Girish? All right, we have got good question here. All right, good. Now there's a question from Damodaran. So is the rules programmed by the user? Since seems like a data in motion a stream filter. So I mean the rules are not programmed by the user, and HBase has already have all of these functionalities in place. All right. The only rule which could be configured from the user is how do we compute the hash code, or how do we compute the list for Watchman 0. Okay, that is something which could be configured, but in HBase that's already pre-planned. Okay. All right, we have another question from Praveen. The keys that we add to Bloom filter, are these the keys or the values in a hash table? Basically, they are the row keys. Based on the row keys, the Bloom filter is generated. Bloom filter generates the data for the row key. All right, makes sense, Praveen? All right, good. So this is a general concept. It's not, a Bloom filter is not only specific to HBase. It's used in various kinds of problem solving. It's used even by the crawlers such as Google crawler to quickly identify whether a website is being crawled by somebody or website is already crawled. Okay, so to identify those kind of things quickly, Bloom filter is a good concept. Okay, when you have to quickly say no, but your yes might take time, in those cases you will take Bloom, you will be okay with Bloom filter. Okay, when you need a no as answer very quickly, but your yes might get delay, that's okay with you. In all those cases, Bloom filter will make sense to you. All right. So that was a Bloom filter. Then there is a concept of a coprocessor. If you are into edge-based development, you should definitely have a look at coprocessor. Meaning, what does coprocessor do? A coprocessor lets you control the the everything about reading or writing in HBase. So you could create hooks. You could create hooks that when user is writing data into this table, let my hook be called before writing or after writing. Similarly, you could create a hook which can be called after reading or before reading. So you could create all kinds of hooks, and these are called coprocessors. These coprocessors are very powerful and very useful. Say for example, say for example you are trying to build your own security or kind of authentication or authorization kind of a system. You could simply create a coprocessor and create methods like pre-get. Okay, you could say, you could implement or override a pre-get method in your coprocessor and say that, okay, if you are not allowed, I'll throw an error. Okay, and therefore user will not be able to access whatever data you do not want them to access. So if you are able to create coprocessors, you can do wonders, as in you can you can stop user from accessing some data, or you could even do various kinds of validation check before the data is getting written into HBase. All right. So those are coprocessors, and this here you can see clearly that we are creating a class that extends the base reason observer coprocessor, and we are overriding pre-get. All right. We could also override pre-put. We could also override the pre-delete or post-delete. Okay. So this will do I mean, this class is called coprocessor. Now there are multiple ways you can, once you have created this class, you could you could basically get it executed or get it hooked into HBase by multiple ways. The first mechanism is you create an XML file in which you put this class, you put the class name, copy this jar file into HBase jar folder, and mention its name in the HBase site.xml. Okay, and also mention the class names, whatever classes you have created, you mention the class names, and then you have to restart HBase. Or if you are not interested in restarting HBase, what you could do is you could create a special kind of value inside the table itself. Okay? If you are creating a value like coprocessor $1, that means anything you put in there is going to be your coprocessor. Okay? So what you can do is you can put this jar folder somewhere in the database. Okay, somewhere in the database, and then you can take this jar, all right, and here you can put that jar into the table itself, all right. So this way you'll be able to put this particular class into the table without having to without so here you can take a look at exact what happens. Okay, all right. So so you can basically mention in the value that this is a coprocessor and the URL of the coprocessor is this one, and this is a class name which we want to get executed as hook, and these need to be prioritized as user. So once that is done, you don't have to restart HBase every time you will be creating. I mean putting the data, your putting the data or getting the data, your coprocessor will get executed. Arvind's question is this similar to MVC concept? That is correct. And so Srisha is saying, can you show practically the concept practically? Right now, I do not have the environment ready for this, but I can try probably later point of time. I'll just make a note of it. All right. So maybe I can create a separate video and upload it and make it available separately, because it'll take a bit of time to create the coprocessor and make it run. All right. So let me take care of this. All right. Is the coprocessor a software module or ASIC? I did not get this. Mm, coprocessor is a software module. So basically, you could hook the software onto the table, just like you have triggers. The way you define triggers in your database, coprocessor is exactly the same concept. All right. Now, although the name sounds like it's a chip because we talk about processor in this, but it's basically a processing unit, a logical unit. Now, here is a question from Arvind. One question: if we can restrict any user by coprocessor, then why do we need Bloom filter? So coprocessor is good when the user is trying to read a particular piece of data or write a particular piece of data. But if your database is getting loaded while searching for a row key, then Bloom filter will come for the rescue, because this coprocessor is not really optimizing anything. Coprocessor is acting like a event triggers. It's not helping, it's not an optimization step. All right. So coprocessor does not help you or make it faster to do the search, but the the Bloom filter makes it faster. All right. Coprocessor gives you the various kinds of control at various kinds of places. All right. Now let's have a look at the REST interface. A REST interface is nothing but being able to call a URL and get the work done. from inside the browser or from inside any HTTP client. You do not need you do not need any special client built for calling the REST. Your browser can do the REST calls. And this is very, very useful. Why? Because in case you are trying to present data using your JavaScript, such as if your data is lying in HBase and you want to display the data inside your website, probably using a REST call will be the easiest one. You could use D3JS kind of a graphs to represent your data, but your data can lie in HBase. Okay, and how to get it done? Basically, you can make a call to your database like this. But before that, you will let me enable this web interface. Okay, so the way we enable it is by saying HBase REST start at this particular port. So now our HBase REST interface has started. You can see the Jetty server. Jetty server is similar to Apache Tomcat. All right, it's a web server. So you can see this is the way we can actually access our table. So it says that there is no such table called my table. Let's have a look at some table which is there already. Let's say we have got 20 June. Let's copy this and put it in the URL. We call it, instead of my table, we call it 20 June. And then inside the 20 June, we would have column family CF1, and the row is, so let me just from the shell itself, so we could say HBase shell, and let me scan 20 June. We can say scan 20 June. Scan 20 June. Okay, so we have got row 1. Alright, that's our row 1. And we have column family 1 and column 1. Okay, so you can see the results returned. The result is returned in the form of an XML. And this XML you can say include in your page, or you can make a JSON call and get this XML, parse it, and then save it in the data. All right. There is something wrong with it. So we are saying oh, this is actually encoded data. This is actually encoded data. If you decode this data, you will get the actual value. Alright, so you can make a call to the server and get the data from within the browser itself. From within the browser itself. Alright. Okay, so those who are wondering what exactly is this is basically a URL scheme. Every URL, whether URL or URI, has got a scheme. A scheme could be HTTP, HTTPS, FTP, or it could be some other mechanism. So, and then colon slash slash is something which has been accepted in all REST calls as a standard. And then you have user login colon password at server, whatever server you are connecting to. This user colon password at is optional. this section, the user info, is optional. The server name is mandatory, and then port, if you do not provide, it is picked up based on the default port designated for that particular scheme. Say for example, if it's an HTTP scheme, then if you do not provide port, the default port that is going to be assumed is 80. And after this 80 port, this everything else is sort of the URL, starting with the path, then the file name, the parameter, the query, and the fragment. The fragment is an interesting part out of this. The fragment is something which does not reach the server. It is only for the client. So, this is what it meant by the URL, and you can have a look at this whole grammar and make a call to the URL to get or set, as in get and put the data. All right. Now we have a question from Carl. Is the REST interface the only way to retrieve the data from HBase remotely? Not really. There are APIs, and there are thrift kind of APIs, which means there are APIs to HBase in probably all of the language possible. Okay, so other than REST, you can also make a call to the HBase client. All right, does it make sense to you, Carl? And most importantly, there are these nice JDBC kind of clients such as phoenix.apache.org, which are really powerful, which gives you an interface like that of a JDBC so that you can connect to the HBase as if you're connecting to a traditional database. All right. So this is very powerful and quite used often. All right. So that's about it. That's about HBase. So any questions here before we move on to another cool topic? No questions? All right. Great. So either I'm really good or I'm really bad because there are no questions. Most likely, most likely I confused you thoroughly so that you have no questions. That's correct. So Damodaran is saying that it takes time to digest. That I completely agree. That I completely agree. All right. Have I put all of you to sleep or something? I only see Damodaran, Kal, Arvind, and Srisha awake. Okay. All right. All right. Great. Great. So you guys look awake. All right. So should we move on to the next topic for today? These are really, really highly compressed course. Okay. It's a highly compressed course, and probably this course gives you a full 360 view of big data. So the next thing which we are going to discuss, let me see what is it that we are going to discuss. All right. So the next thing which we are going to discuss is called Zookeeper. So in case of Zookeeper, although it's not something which people expect in the interview or expect in in their job profile, but it is very important to know Zookeeper, because just like HDFS, Zookeeper is the component on which probably everyone else depends. For example, when we talk about region servers and HBase master, they all use Zookeeper. Similarly, HDFS also internally use Zookeeper, and you can also put Zookeeper to your own use. So that is the reason why we are going to discuss Zookeeper in detail, because Zookeeper is a very important component of the whole ecosystem. All right. So here we go. So here is an open-ended question. The open-ended question means that there are many answers. There's not a single correct answer. So how would email processor avoid reading the same email? Imagine that there is an inbox and there are email processors. And what do these email processors do? Let's take a case of somebody is trying to create an index out of the email. Creating index means creating the unique list of words and noting that down where exactly it is found. Okay, so email processors have to process emails. As soon as the email comes in, email processors would be kicking in and then do the processing. So in these circumstances, these email processors are running on multiple machines. They might end up reading the same method, say same emails. How would you avoid such kind of scenarios? Anyone? How would you avoid email processors trying to read the same emails? Multiple email processors trying to index the same email. Arvind Damodaran, Girish, Srisha, Kal, Krupa, Praveen, Santosh, Savita, Subbareddy. Damodaran says, let's by using a locking. So we could do a locking in the sense that we could lock the inbox, and then every email processor could lock one in email so that others cannot. That's a good answer. But what if we are not allowed to lock the inbox? Instead, we have one more information for you, that each email has got a unique identifier. Okay, good, good. Santosh is saying mark every email as read so that other processors don't reread the same email. Perfect, perfect. And this is how actually I had implemented my uh, email processors last time, by marking the email as read. Okay, but for argument's sake, let's say these email processors do not have permission to change the state of the email. Okay, so Damodaran says do a read copy update. So we know that each email has got an ID which is unique. Okay, so any other strategy without trying to change the inbox? Yeah, Santosh? Yes. So Damodaran says that read copy update or RCU locks are normal sync mechanisms when too many consumers access the same resource. That's correct. Praveen says that use asynchronous messaging. Mhm. So, do you mean to say that we have? Uh, do you mean to say that you use thread safe APIs, Praveen? Santosh is saying split and distribute emails to each processors based on email ID. Okay, so these email IDs don't have. Let's say they have random numbers. They have some random numbers. They are not really sequential. Okay, okay. So what Praveen has suggested is use synchronous messaging using queues. Interesting, interesting. So Santosh is suggesting that we could split and distribute the email to each processors based on their ID. Okay, that's good. That's good. But who will do the distribution? Okay, Carl has another suggestion. He says that add IDs to a set and each processor checks the set of IDs to check whether the okay, so this is twice, and I think the approach by Praveen is also same, okay, using queues. Okay, so basically, these both the approaches are using a third-party database or any other data storage mechanism to store the state of email. Okay, all right. Uh, and same is the answer from Srisha. Just save the IDs, which all we need. Okay. So Bloom filter, how can we use Bloom filter in this game? Mm, okay, but for Bloom filter, where are we going to pick it? I'll have to think about it. All right. So Santosh is saying that we devise a kind of a convention that say we have 1 to 100 can go to email processor 1 etc. Okay. Okay, that's also interesting way to look at it. But if you no matter what we decide upon this, there are heavy chances that some of the processors might get overly busy while other remains free, and thus causing the delay in in the processing of the email. Okay, good, good, good. So Damodaran says we could have a proxy that maintains all the information of email and storage information, so each processor can query the proxy only, and proxy provides the hash to the physical email. That's good. That's good. So we all are coming to this kind of a conclusion. Okay, we have a third party service where the we can maintain the state of each one. Email processor goes to the server, reads an email, and immediately before it starts processing the email, it checks whether somebody is accessing it or not. If somebody is accessing it already, then drop this and try to get hold of second email ID using this service. Okay, so now if we have multiple email processors, again the problem whatever we are facing here might also occur here. If this box does not provide a asynchronous or I mean does not provide thread safe mechanism, then we might end up corrupting the data, and thus it may not work really well. This is where Zookeeper comes into play. This box is what Zookeeper is. A zookeeper provides you a way of coordination between multiple machines. And it is very obvious that whenever there is going to be multiple machines, whenever there are going to be a distributed computing, a coordinator would be required. A policeman on the cross section will be required, which will coordinate the multiple readers and writers. And that's what the zookeeper is. A zookeeper is a distributed coordination service for distributed application. The way our email processors were running parallelly on multiple machines, the zookeeper provides a way to provides a service to all of such systems. Okay, because such systems are called distributed applications. So every distributed application exposes needs various kinds of functionalities, and those functionalities are provided by zookeeper. So zookeeper provides a simple set of primitives which can be used many by many programs in an organization. It's very easy to program to. Uses data model as if it's a directory structure. So you can always think of zookeeper that it's some sort of a central file system in which people can keep on reading, writing, and using this location as a flag or as a note. All right. So there are minor differences from directory tree. We'll talk about those later. It can be used for synchronization, configuration maintenance, and it does not suffer from race condition or deadlocks. Race condition means Race condition means, can anybody tell me a quick one-liner definition of race condition? Anyone? What is a race condition? Damodaran says racing towards deadlock. Interesting. Giri says too many requests. Okay. In a queue. Okay. Praveen says two threads trying to access the same variable. Okay. Carl says more than one process is trying to access the same data without knowing a state change from either process. Good, good. Basically, two actors or two processes competing for a resource. That's what all of you have said. So race condition means two processes competing for a resource. And thus, in case this resource is not thread safe, these two processes might end up corrupting that data. Okay, imagine this. You went to the ATM machine, ATM box, ATM room, and there are two machines side by side. Okay, so you insert card into one, take it out, and it shows that the amount in your account is say 100 rupees or say 1000 rupees. So, and parallelly, you quickly insert the card into the second machine as well. Now, the second one also shows that it has got 1000 rupees. Now, you take out 100 rupees from both the ATMs. Okay? And and then if it's not thread safe, at the same time, what would happen is you will take out 200 rupees and your account will have 900 rupees left in your bank account, which effectively, so two processes were competing for the same resource, which is two ATMs are trying to compete for your bank balance, and thus they might end up corrupting the data. This is called a race condition. Okay. Okay, so Damodran is also saying trying to access the same resource at the same time by many process. Okay. And Srisha says within a single clock up times tries to access more than once. That's correct. Yes. So race conditions are very difficult to solve. I have not seen a single program in my career which did not suffer from race conditions, a single software. So whenever I used to audit the tools, I found that race condition was probably everywhere. Even in the Unix commands like password command, the race conditions exist. So race conditions are very difficult to solve problems. And similar are the deadlocks. The deadlocks are a A process is waiting for B to finish, and B is waiting for C to finish, and C is waiting for A to finish. So A, B, and C are in deadlock. Now, this sounds very hypothetical when we talk about such kind of system. Okay, when we talk about such kind of deadlocks, they sound like very hypothetical, but irony is they are very much everywhere. Okay, let's take a case of we are trying to alter a particular table. So we start a transaction on that table. Okay, and in the meantime we are trying to add in a single transaction. In a single transaction we have modified a table. Now there is another transaction happening parallelly on which our current transaction depends upon, and that transaction is modifying the current table as well. So inside our code, our one transaction is depending upon the another transaction, and that transaction internally is depending on this table and effectively causing the deadlock. And trust me, deadlocks are a very common phenomenon. So Zookeeper does not suffer from race condition or deadlock. So Carl's question is, how does Zookeeper prevent race conditions and does it does it maintain a queue of requests and process these requests sequentially? Brilliant. So yes, that's how it does it. Okay. So yes, this is how it actually avoids all these race conditions and maintains the synchronization and also avoids deadlock. Okay, so the design of a zookeeper is quite simple. It's a hierarchical namespace which looks like a standard file system, but internally it's like a tree. If you remember your data structure classes by any chance, or or any other tree you can think of, where there is a root node and then there is a branches, there are children nodes. Children node can have further children, as well as each child can store the data. All right, so it's made up of nodes which are called z node, means zookeeper nodes, and each node can store data and each node can have further children. Data is kept in the memory as well as in the disk. Alright? So it achieves high throughput and low latency numbers. Really high throughput and very low latency. And throughput means number of requests being catered by a system, while low latency means each request is taking very less amount of time. High performance as in used in a large distributed system. Highly available as in there is no single point of failure. This is something which is very different from all the systems which we have studied so far. We studied HDFS, we studied yarn, we studied HBase. So in all of these systems, there was a single point of failure. Okay, here there is no single point of failure. In all the systems which we have studied so far, everywhere there was a master, there were slaves, and we designated who is going to be master. That is not the case in case of zookeeper. All right, and again, it provides you strictly ordered access using the synchronization. All right. So that was the basics of design from the user point of view. Now we talk about replicated or highly available mode. So a zookeeper is not a single machine, though for a user it might look like it's a single machine on which our data is there. There is a node, there is a tree in which we can add the data, but internally it's a bunch of machines. This bunch of machines are called these bunch of machines are called the what do you call them? The ensemble of zookeeper. So there is a zookeeper machine. There is a bunch of machines which are designated to run zookeeper parallelly across the cluster. The client will keep a TCP connection with the zookeeper service and will keep on getting the notification from the zookeeper about various events, and zookeeper keeps on sending a ping sorry the client keeps on sending the ping to the zookeeper even if the client is not using the zookeeper or is not asking for it. So the client will keep on uh, sending the heartbeat to the zookeeper that I am awake, don't expire my session. The way a bank website expires your session if you do not touch it for some time, in the similar way zookeeper expires the session, so that it can quickly figure out which clients are alive and which clients are dead. If client is alive, it has to send the ping to the server. Okay. In case there is a connectivity break broken by the client, okay, there is a network issue or something, the client automatically connects to the server again. Okay, to another server. If one server goes down, it connects to another. If that goes down, it connects to another. So the client library takes care of this complexity of sending heartbeat every now and then, as well as switching between multiple servers. All right. The third design aspect of a zookeeper is that the updates are strictly ordered for transactions, for synchronization, for avoiding race conditions and deadlocks. So every update, every change that goes into Zookeeper has got a unique number marked on it that keeps on increasing. All right. It's really fast. It has to be fast, and the the reads are 10 times faster than when the reads are 10 times more than the writes, then it performs really great. Okay, so it has been tested and tried at Yahoo, and it was benchmarked over 10,000 operation per second in the right dominant workloads. Okay, let me see if there are any questions. All right, so here we go. let's first check let's first check these four letter commands. We call them four letter commands because they are just to check the status of the server. Okay, you could say things like, you could say echo, are you okay? And we say, at the same time we could also connect to localhost 2181. So it says I'm okay. So Zookeeper is running at 2181 port, and NC localhost means we are connecting to this port. Okay, we are connecting to this port and piping this data. Are you okay data we are echoing into NC. Also, we could do it the same thing in a more obvious way. We could say NC localhost 2181 and say, are you okay? And it says, I am okay. See that? Similarly, if you want to see what's the configuration of server, you could say things like conf. Alright? So this is the four letter commands to check the status quickly. To install Zookeeper, you can simply download it from there and then start it. This way it will in start in a single mode. To install it in a cluster mode requires far more effort and will not be possible to cover in today's session. Okay, so again, back to the data model. The way data is stored in Zookeeper is in the form of tree. The topmost one is slash. Under that, whatever node you create is called slash whatever name you give it. Let's say we created zoo. Under that, if you are creating duck, goat, cow, their URL is slash zoo slash duck. Okay, so a better way would be to do it parallelly. So, so we could launch Zookeeper client and say status. Let me also check whether everything is up or not. So Damodaran's question is, why am I using the Unix command here? So echo means we are trying to print that. If we, let me exit from here. When we say echo, are you okay? Okay, so it's basically printing whatever we are providing on the command line to this std out. We can pipe that to another command. Let's say here we are piping it to wc. Then you get these, you see that 5 characters. Similarly, we are piping the are you okay to the localhost and 2181 port, correct? Instead of connecting to localhost at this and then typing are you okay, we got it done in a single command. Alright, so you can see that the Zookeeper is up. It says there are 4 clients and the server is up. And here this diagram shows you nicely a tree structure. The same thing can be seen if you try to log in into Zookeeper. Okay, so now it shows you that it has been connected. And when we can say ls and ls slash, so it shows you that these are the nodes at the top level. Okay, these are the top, these are the nodes at the top level. Okay, let's see what is there in zoo. Okay, there are these nodes under zoo. All right. And we can also say get the data from slash Jew. It says there is no data in slash Jew. And what about slash? There is no data in slash also. All right. So each node is called Z node. It can have children, it can have data. It forms a hierarchical namespace. Z node also has access control lists, and the only few differences between the file system and this one is slash a slash dot dot does not have a special significance here. Dot does not have a special significance here, and it does not provide you append operations. Okay, it only provides you the quick addition operations. All right, I mean quick updation operations, not append. Also, the data access is atomic, whether you get it or you don't get it. There are multiple kinds of Z nodes. First one is persistent. The way you can create a persistent node is straightforward. We could say slash and we could say 11 JUL and we can put some data inside it. So we are successfully able to create this particular node. So it is on the top node. You can see that it is on slash as a top level node. Even if you exit it and come back and join again, this node will exist. It has been persisted. Now these are the most common form of nodes. Now there are something called ephemeral nodes. Ephemeral nodes have this interesting property that in case the client gets disconnected or clients disconnect, these ephemeral nodes disappear. Okay, these ephemeral nodes mark the presence of the client who created them. In case the client get disconnected or client is dead, these nodes will get deleted. So a client can mark its presence using ephemeral nodes. So we can create ephemeral node by using -e and say 11 July. Under that we can create my EPH with some data with some data. Okay, so we have created one ephemeral node. All right, an ephemeral node, since it will disappear the moment we disconnect. So right now we have disconnected and it shows that this probably this node is going to get disconnected, deleted. Okay, so you can see, okay, my ephemeral node right now is existing, but after some time time is going to get expired and this node will automatically disappear because the client who connected to the server has already disconnected. So let's see. Okay, so it is still existing. A ephemeral node cannot have children, though it is connected to, it is basically marking the presence of the client's session. It is visible to everyone. Let me see if it is there. Yeah, it has disappeared. You can see that. Also, there is a third kind of a node called sequential node. So sequential node is another interesting idea. Okay, so sequential node is automatically given a name by the system. We only provide a prefix name. Let's say I'm providing some prefix called my prefix and I'm providing some data. So we say create -s, the parent folder along with the prefix, and then we provide data. So instead of creating a node with the name called my prefix, it will create a node with that prefix and suffixing a big number. You see that number? So yeah. So every time you execute it, a new node is being created with a newer name. You can see that. These are called sequential nodes. Alright, you can imagine that there is going to be the utility of sequential node specifically in the systems where an ID matters. For example, let's say you are building a ticketing system. Every time a request is logged, you need a new number to be created. And this is very important. Reason being that creating a new ID parallelly is very difficult thing. If you think about creating a new ID parallelly by uh, for a system where there are thousands of requests per second is a very difficult game. In those cases, the sequential G node comes for a rescue. Okay, this number is generated, it starts from 0000 and goes keeps on monotonously increasing for each parent node. Okay, if we try to create another node, let's say we create some other node. Okay, if we try to create another node, let's say we are creating a permanent node called X under that. Okay, if we are creating this, so we here, if we try to create, let's say, one sequential node under X, it will start from 0 again. Okay, so every parent nodes, the sequences start from 0. All right. Okay, so there are various other kind of operations such as checking for whether the node exists or not, getting ACL or setting access control list, getting children, setting data or getting data, and synchronizing the client view. Okay, so all these operations which we did just now, creating a node, getting data from node, and maybe deleting a node, they can be batched together in a single transaction. Alright, now you must be wondering, before we go forward, you must be wondering, when Zookeeper is so powerful, Zookeeper is available, Zookeeper is fairly consistent, and Zookeeper is also so well thread safe. Why don't we use Zookeeper for everything? Why don't we use Zookeeper even instead of HBase or any other database? The simple answer is Zookeeper is only great if you have small data. It's a coordination service. It's not a data storage. It's a coordination service which can help you storing few MBs of data or few hundred MBs of data, not beyond it. Okay? All right. Next is that the APIs for Zookeeper are provided basically in Java and C. The community has contributed the APIs for Perl and Python and Rest. But the most interesting aspect about the API of Zookeeper is Zookeeper is the only one which I have used so far where every function is implemented as synchronous as well as asynchronous. Okay, and the difference is, can anybody tell the difference between asynchronous and synchronous? The difference between synchronous and asynchronous call is, Praveen says sync means instant response. Okay, and Damodaran says serially and unserially. Okay, interesting. In case of sync, what happens is that your program will wait until, your program will wait before it executes next command. It will wait for your function to return, which means your function might be returning some value, right? But in case of asynchronous, the functions return nothing. Functions return value is void, and you do not wait for the function to complete. Instead, you say that, okay, get this work done and let me know by the way of this particular execution of function. So you provide something called a callback, and you provide all the arguments, and let this function get executed, and once that function will finish, your callback is going to be called. Yes, that's correct, Girish. Sync, like it needs instant response. Async can wait. Blocking versus non-blocking. That's correct, Carl. So the sync method is blocking, as in it the whole processing will wait. The processor will, the computer will wait until this function finishes. While this is non-blocking, as in when you call it, it will immediately move to the next instruction, while it will execute the callback after the exist finishes. That's correct, Arvind. Great. So that's about a little bit about Zookeeper. Zookeeper also provides you watches. The clients get notification whenever Z node changes in some way, or Z node something happens on Z nodes or Z nodes. Watches for Z nodes are triggered only once. If you want multiple notification, you will have to re-register inside the watchers. Alright, let's continue from the watch triggers in the next session on the coming Saturday. And if you have any questions, drop me an email. We can take care of it. All right. Thank you very much. And I'm in process. We are in process of reviewing people's assignment. So if you are done, if you have given your final shot in case of subjective assignments, let us know so that we can start reviewing your assignment. Because in our case, we let our users attempt every question multiple times. Therefore, we generally are not sure whether the user has finished or user is actually working on an assignment. Okay, so Carl, for HBase, there is a problem in the no big data LMS. You have a look at the problem. The problem statement is the email one. Have a look at that one. Okay. If you have any doubts, let me know. Okay. So assignments are very straightforward and simple. If there is any doubt, just let me know. Okay. So if you dedicatedly give 30 minutes, that should be good enough. All right. All right. Have a great week ahead. Thank you very much. All right. Thank you, Arvind. Thank you, Damodaran. Thank you, Girish. Thank you, Shrisha. Thank you, Carl. Thank you, Krupa. Thank you, Praveen. Thank you, Santosh. Thank you, Savita and Supareddy. You have a nice week and have a great day. Our upcoming classes are coming. You can refer to your friends. All right. All right. Have a great week ahead.